let's look at what happens in free fall, and let's compare what happens to the kinetic energy of an object compared to what happens to the potential energy of an object. So let's consider an object that's dropped from this height y initial. When it's dropped, I know that the kinetic energy is 0 because that initial speed will be 0, and the potential energy is the biggest value that it's ever going to be, because when I drop this object's just going to go lower and lower and lower, so its y position will decrease. And because our potential energy is equal to mg times y, as y decreases, this value is going to decrease. So I know that my potential energy is at a maximum when it's at the highest position. So a few moments later, when the ball is at a lower position, what can we say about the kinetic energy? Well, we already know that as the object falls, it's going to go faster and faster and faster, which means the kinetic energy increases. So the kinetic energy increases, and because it's going to a lower and lower position, the potential energy decreases. And it's not a coincidence that as the kinetic energy gets bigger, the potential energy gets smaller. Now, when we reach the very, very bottom, this is before it touches the ground, the kinetic energy is at a maximum. It's the biggest value that this will ever have, because when you drop an object, the fastest it's ever going is right before it hits the ground. So the kinetic energy is at its maximum value. And right before it hits the ground, or right when it hits the ground, that's when the y position is equal to 0, so our potential energy there is equal to 0. So just looking at this, it looks like we start off with lots of potential energy and no kinetic energy. As we start to fall and we lose potential energy, we gain kinetic energy. So what's really happening is that our potential energy is being converted into kinetic energy. This is what happens as an object falls. Potential energy is converted into kinetic energy. And as it turns out, and we'll explain this a little bit more later, the total mechanical energy, remember E, that variable E, total mechanical energy, which is K plus U, that total mechanical energy remains constant when the object is in free fall. So if the object loses 5 joules of kinetic energy at this point, it will have gained 5 joules of if it loses 5 joules of potential energy at this point, it will have gained 5 joules of kinetic energy at this point. Exactly how much potential energy it loses is exactly the same as how much kinetic energy it's gaining, so that the total of K plus U remains constant. And this is an equation that describes that total mechanical energy remains constant, because remember, total mechanical energy is just equal to K plus U. So what I'm saying here is whatever K plus U is at one moment in time has to be the same as K plus U at some later moment in time. So we're going to use this equation a lot to solve a lot of problems, and we just need to be careful about, when I say I here, that means initial. Well, what does initial mean? You are going to have to define an initial event. Maybe the initial event is when the object is dropped. And you will also have to define a final event. And you're going to choose your initial event and your final event to be the 2 points in time where you know what some of these values are, or where you want to find out what some of these values are. And then the equation becomes pretty simple, and it eventually becomes like a plug and chug. Let me also mention that the sample that I've shown here is just when an object is dropped and it's falling downwards. But all of this is still true for an object that is shot upwards. Let's imagine what happens to an object that is shot upwards, okay? When it's first shot, it's going to have the highest speed that it ever has, because we know that as it goes higher and higher and higher, it's going to slow down. So as it goes higher, it's going to lose kinetic energy, right? Because I'm going slower and slower. V gets smaller and smaller. My kinetic energy is equal to 1/2 mv squared. So as V gets smaller as we go higher, our kinetic energy also gets smaller. On the other hand, as we go higher, the y value of our position increases, so our potential energy will increase as we go higher up. So as we go higher up, our kinetic energy decreases, our potential energy increases. The sum of those two things stays constant. And that's what we have here with this equation. Okay, so this is a very powerful equation, and in the next few slides I'll show you how we can use this equation. first let's take a second to think about this problem. So press pause, read through it, and think of an answer. There's your answer choices. And then when you want to go through it with me, press play again. Okay, so this might not be totally intuitive, but you might want to say that this one's going to be going the fastest when it falls because you're shooting it downwards. Or maybe some people will think that A is going the fastest when it reaches the ground because it's in the air for so much longer. But as it turns out, they all will have the same speed at the bottom. Why is that true? Well, we can think about this in terms of conservation of energy. They all start from the same height. So they all start with the same potential energy. They all reach the same height in the end, so they all end up with the same potential energy. Initially, they are all shot with the same speed. That means that they all have the same initial kinetic energy. And because everything else is the same, that means that when they reach the bottom, they will also have the same kinetic energy. The three of them will have the same amount of kinetic energy. So I could say, Ki is the same for all three because they're shot with the same speed. Ui, that initial potential energy, is the same because they're all shot from the same height. So Ki plus Ui is the same for all of them. And then when they get down here, they're going to have the same amount of potential energy. That's Uf will be the same. So they have to have the same amount of kinetic energy, Kf, which means they'll all be going at the same speed.